All right, folks, it's Bass Action back in action here. On this video, we're going to work through some calculator work. And although I can't show you the calculator on the screen here, you will want a scientific calculator handy. I want you to actually type these numbers in your calculator. And if you can't get the numbers that I'm writing, then I want you to talk to me in class. Make sure that you bring a scientific calculator to class because I do not have those to lend, and you won't have a way to get these numbers otherwise. All right, so let's start up here at the top with our common logarithm. Under this little recall section up here at the top. So our common log has a base of 10, and we've been talking about that, and that what we can do is we can write that, let me fill that in, that we can write that as a log base 10 of x. But what we've also talked about is that that statement is mathematically equivalent to a log x. It's this second notation right here that's going to be useful for us in terms of our calculator. That's the notation we'll find on the calculator. And some of you might recall how these were typed in last year in your Algebra 2 classes. Our natural logarithm is a base of e, so we certainly could write that with a log base e of x. And this first notation is very convenient if we're solving an equation. We're trying to move back and forth between a logarithmic or an exponential notation. But our calculator notation that's going to be much more useful for us is this lnx. So it's this notation here that we're going to use when we're thinking about typing into our calculator. So first, let's just do a little bit of calculator work. Have your calculator handy. And what we want to do on this example A is we want to type in log 5. Now that's our common log, so we have to make sure to press the right button and divide it by 10. Now when you type this in your calculator, depending on your calculator, how it does the parentheses, you may need to actually put a closing parenthesis after the 5. So your calculator might start a parenthesis for you, and you need to close that. So when we type in this log 5 and we divide it by 10, if we are specifically going to round to 3 decimal places, that's our standard. When we round this to 3 decimal places, we should get 0.06, and then we're going to say 070. There, sorry, I wrote that funny there. I got ahead of myself. As we type this in when it comes up on our screen, we're going to see a 0.06989. So it's going to be 0.06989 and so on. But if we want to round that to 3 decimal places, if we're rounding it to 3 decimal places, we look to the number to the right. It's going to tell us to bump that 9 to a 0. So our answer is going to be 0.070. Okay, on to the next one. What I want you to notice here is that I do have a mix of logarithms here. I have a natural log in the numerator, and I have a common log in the denominator. So you've got to be really careful on what you're typing into your calculator there. And when we type that one into our calculator, what we're going to get, if I write these all out, I'm going to get 3.07011, and again we're going to round to the 3rd decimal place, so in this case we can just chop it off. We don't need to do any rounding there. So that would be our final answer. On the next one, when we type that in, again you're going to have to be careful because you may need to close some parentheses each time you type these new logarithms, and so you got to be careful with that. More often than not, what I will do is I will type in my entire numerator, I'll press enter, then hit divided by, and then use some parentheses to put around this entire denominator. This one can be pretty complicated, so if you can't get this, definitely ask me in class and we'll walk through it. But the decimal approximation you're shooting for there is a negative 1.418. Okay, so the next thing we want to take a look at here is this change of base formula. The next video in the playlist is a proof of this change of base formula, and I would like you to watch that. So on this change of base formula, you'll recall this from your previous classes. Our calculators only do that base 10 and the base e. So if I have some logarithm, let's say like this, with a base that I don't no, it's not a base 10 or a base E, I can rewrite it with a base 10 by writing a base 10 log of the argument with a base 10 in the numerator and a log of a base 10 of the base in the denominator. It doesn't matter whether I would choose to do this as a common log or a natural log. It doesn't matter. Log of the argument goes in the numerator, log of the base goes in the denominator. So just real quickly, if we come down here, let's say that we needed to figure out what log base 5 of 89 is. Now that doesn't directly type into most of our calculators, so I can rewrite this with change of base by looking at it either as a log 89 over a log 5, and then we're back to some calculator work, or I can write it as a natural log of 89 and a natural log of 5. I oftentimes will choose the natural log simply because it's fewer letters to write, but it doesn't actually make any difference. What does matter is that whatever base of the log you choose for the numerator, you have to choose the same for the denominator. You can't mix and match like we saw in some of our examples up above. So when you type this one in your calculator, again, rounding to 3 decimal places, you should get 2.789. So just make sure you can get that. Our next one, it's also going to look kind of weird, but it's no big deal. I can write it as log square root of 5 over log square root of 2. Or I could use the natural log, which is certainly less writing, natural log square root of 5 over natural log square root of 2. And if it seems weird that those two are going to give you the same answer, I would encourage you to type them both into your calculator and show yourself, just prove to yourself that you get the same. So we're going to get an approximate here of 2.322. So again, make sure that you've typed those in so you're prepared for that in class. Watch the change of base video and we're good to go.